In this lab, I want to demonstrate a point line joint. So a point line joint has 4 degrees of freedom. If I go to the properties, we see that it has one translational degree of freedom, is it can move on a straight line along this axis, and it has 3 rotational degrees of freedom. So it can rotate around this axis, and it can rotate around this axis, and it can rotate around this axis. So 1 translational, 3 rotational degrees of freedom. And if I test that out, then I'll drag the part and we'll see that it will translate, so it'll move in a straight line. It's also rotating as I move it around. And then I've put a 3D contact on here so that when it comes in contact with the edge of that channel, it stops. Now again, if we move it too fast, we can overrun the calculations, and then we can get it into a position sometimes where it cannot continue, in which case we would simply right click, suppress that 3D contact joint, get it back into a valid position, and then unsuppress the 3D contact. So let's look at how to set this up. So earlier we created a ball with a stem on it, and I also saved this sketch as the file name channel. So let's go ahead and extrude this portion right in here, and I'm going to do that mid-plane, a distance of 12 inches. I'll then change the color of this part to some other color. I'm going to use blue. You could use whatever color you like. I then start a new assembly, and I save this assembly with the name point line joint, and I'll do place, and I will get my channel and I'll right click and place that grounded at origin. And then I will do place, and I'll go into the previous folder, the spherical joint, and I'll get that ball with peg, and I'll place that anywhere on the screen. And then to place this, I could use the implied axis of this channel, but we saw on the previous problem it's best if we use the origin geometry. So I'm going to do constrain, and I'll select the axis of the channel, and then I'll select the point in the center point of the ball, and it moves that over into position. Now in the assembly environment, we have the kinematics of that is it can move along that line, but we don't get gravity, friction, forces, so forth. We could put a contact set on this, but let's just go directly into dynamic simulation. So I'll go into environments, dynamic simulation, and we have seen in the past that we can go to the simulation settings, turn this off, manually put our joints on there, but I think you get the idea on that now, so I'm not going to do that. I'll just leave the automatic conversion of the assembly make constraint into a point line joint. I drag this, and right now we'll see that it goes right through the channel. Now keep in mind that when we made this ball, we allowed a little bit of clearance between this ball and the channel so that it isn't always in contact. Otherwise it would always be in contact. And then we'll put in our 3D contact. So I'll do my 3D contact, and I'll select the first component, and I normally select the components that's in the grounded group first, although I don't really think that it matters. I'll select the second component, and now when I drag this, when it comes over here in contact, it should stop. Now one thing that we'll want to start doing in the future is actually, rather than dragging objects with the mouse, we want to put it under the control of the computer. Now, I'm going to put gravity on this, so I'm going to right click and I'll say define gravity, and I need to select a face to define the direction of gravity. I'm going to select this face, and then I'm going to point that down, so I'll flip that direction so gravity is pointing down. If I want to turn that off, just come over here, click someplace, turn off the glyph, and then I'll play this, and we'll see that it falls over, and then when it comes in contact, it should not fall over any further. So we'll see how to put additional control on this as we go along. So it's just going to oscillate back and forth here, and if I put a friction value on here, it will eventually stop moving. Let's go into that. Whoops, I went through that too quickly. I always click on stop and then rewind, and then go back to construction mode in order to make any changes. 3D contact joint. So I'll go into 3D contact and I'll go to the properties, and right now there is no friction set, and so it could continue to move around unless we put in a friction value. In addition to adding friction values to the 3D contact, we can also add friction values to the different degrees of freedom of the point line joint. And so we'll go in here later and we can put in a friction for the translation. We can do a friction for each of the rotational degrees of freedom. So that was real simple demonstration of point line joint. And again, keep in mind that we've used this example for the demonstration, but anytime you have motion where you have a linear or a straight line translation and rotation motion, keep this joint in mind.